My dear students, in the previous video, I solved one problem in the exercise 3.4, that is finding the inverse of a given 3 by 3 matrix using the elementary row operations or column operations. So by the same method, in this video also, I am going to solve a 3 by 3 matrix, finding the inverse of a 3 by 3 matrix using the elementary operations. We consider the problem number 17. The matrix A is given by 2, 0, minus 1, 5, 1, 0, 0, 1, 3. We have to find out the inverse of this matrix by using the elementary operations. We know the result matrix equation A is I times of A. Identity matrix into A itself. I is the unit matrix of order 3 because it is given as a 3 by 3 matrix. So this is A equal to IA. First, we are convert the first element by 1. For that, I am dividing the first two elements by 2. That is R1 by 2, 2 by 2, 1, 0 by 2, 0, minus 1 by 2. And its remaining rows are as it is, you write 5, 1, 0, 0, 1, 3. The same operation should be carried out on the right hand side. Dividing the first element by 2, 1 by 2, 0 by 2, 0 by 2, 0. And 0, 1, 0, 0, 0, 1. Next, I want to, the second row, first column element, this 5 should become 0. For that, I rewrite R2 by R2 minus 5 times of R. That is 1, 0, minus 1 by 2, as it is first row. Second row, R2 minus 5 R1, that is R2 minus 5 times R1 is 5, 5 minus 5 is 0. R2 minus 5 into 0 is 0, 1 minus 0, 1, 1 minus 0, 0, R2 minus 5 R2, R1, minus and minus plus 5 times of R1 is 5 by 2, minus into minus plus 5 by 2. And the third row 0, 1, 3 as it is. This is your left hand side, similar operation, right hand side, 1 by 2, 0, 0, R2 minus 5 times of R1, R2 minus 5 times of R1 is minus 5 by 2. R2 minus 5 times of R1, 1 minus 0, 1, 0 minus 0, 0, 5 R2. And 0, 0, 1 is infinity. Okay. Next, 1, 0, 0, 0, 1. We convert this one, the third row element, third row, second column element by 0. For that, R3 is R3 minus R2. So next, to convert this third row second column into 0, we write R3 by R3 minus R2. R3 minus R2. For that, 1, 0 minus 1 by 2 as it is, right? 1, 0 minus 1 by 2. R2 minus R3. So R3 minus R2. For that, we rewrite the second row is also as it is 0, 1, 5 by 2. R3 minus R2, 0 minus 0, 1 minus 1, 3 minus 5 by 2. 3 minus 5 by 2 is 1 by 2. It is equal to 1 by 2, 0, 1, sorry, 1 by 2, 0, 0, and minus 5 by 2, 1, 0, R3 minus R2, 0 minus or minus 5 by 2 plus 5 by 2, 0 minus R3 minus R2 minus minus plus by V2 0 R3 minus R2 0 minus 1 minus 1 1 minus 0 1 into A. Again R3, this becomes 1. For that you multiply R3 by 2. R3 is 2 into R3. For that 1 0 minus 1 by 2 0 1 5 by 2 2 into 0 0 2 into 0 0 2 into 1 by 2 1. You multiply that row by 2, 2 into 1 by 2 is 1. So 1 by 2 0 0 minus 5 by 2 1 0 and 2 into R3. 2 into 5 by 2 is 5. 2 into minus 2, 2 into 1 minus 2, 2 into 1 is 2 into A. Okay. Next one. Now you convert this element, second or third column element 5 by 2 is 0 for that. R2 is R2 minus 5 by 2 R3. R2 minus 5 by 2 R3. You multiply R3 by 5 by 2 and subtract from R. That is 1 0 minus 1 by 2. R2 minus 5 by 2 R3. R2 minus 5 by 2 R3 0 minus 0 0. 1 minus 5 by 2 R3 0 1 minus 0 1. And 5 by 2 minus 5 by 2 R3. 5 by 2 minus 5 by 2 0. And 0 0 1. So we are nearing the answer, that is 1 by 2 0 0 R2 minus 5 by 2 R3. 5 into minus 5 by 2 is minus 25 by 2 minus 5 minus 13 by 30 by 2. This is minus 5 by 2 minus 5 into 5 by 2 is minus 25 by 2, that is minus 30 by 2, that is minus 30 by 2 is minus 15. Similarly, minus into minus plus 5 by 2 into 2 is 5. 5 plus 1 is 6. 0 is R2 minus 5 by 2 R3. R2 minus 5 by 2. 2 2's are cancelled. Minus 5 in plus 0 minus 5. Minus 5 plus 0. Minus 5 by 2 into is minus 5 plus 0 is minus 5. And 5 minus 2 2 into A. So one more. This is 1 0 0. This should be 0 for that. R1 minus R1 plus 2 R3. 1 by 2 R3. 1 by 2 R3 plus minus 1 by 2 it becomes 0. So R1 is R1 plus 1 by 2 R3. 1 0 1 plus 1 by 2 R3 is 0. 1 plus 0 is 1. 0 0 0. Minus 1 by 2 plus 1 by 2 into R3 is 1 by 2 plus minus 1 by 2 0. And 0 1 0 0 0 1. Therefore, the left hand side matrix becomes an identity matrix of order 3. Similar operations R1 1 by 2 plus 5 by 2 R3. That is 1 by 2 plus 5 into 1 by 2 is 5 by 2 R3. That is 6 by 2. 6 by 2 is 3. 0 minus plus 1 by 2 R3 is minus 2 into 1 by 2 is minus 1 plus 0 minus 1. And 0 plus 1 by 2 R3 is 1 by 2 is 1. 1 plus 0 is 1. Similarly, minus 15, 6, minus 5, 5 minus 2, 2 into A. So this is I equal to A inverse into A you derived, therefore this matrix is the inverse of the given matrix. Therefore A inverse is this matrix given. This is for A inverse. Answer is answer step only. Last step. Therefore A inverse equal to 3 minus 1, 1. 3 minus 1, 1. Minus 15, 6 minus 5. 5 minus 2, 2. This is the answer for the given problem. Okay? That's all about the problem. This is problem number 17. So one more problem, last problem in the exercise 3.4 is objective type problem. We will see. 18th problem. If A and B are two matrices which are inverse to each other, 18th problem is A and B are two matrices which are inverse to each other. Which are inverses to each other. If it is the case, four conditions are given. One is AB equal to BA. This is A, and B is AB equal to BA equal to 0 matrix. 0. And third C1 is AB, product AB is 0 and product BA is 1. And D, fourth one is AB equal to BA equal to identity. Out of these four answers, what is the correct option? A and B are of two matrices of inverses of each other. That means A is the inverse of B and B is the inverse of A. You know, if A and A inverse are inverse of A inverse is inverse of A, you know A into A inverse equal to A inverse into A equal to identity. This is the result we know. So A inverse we can call it by B. Therefore AB equal to BA equal to I. Option B is your correct answer. That's all about the problem. So exercise 3.4 is we have completed. So and one more thing, if you are 2 by 2 matrix is given, if you find out the inverse of a 2 by 2 matrix, if it inverse exists, you can say one problem in the exercise also. We can see one more problem in the exercise, that is 14th problem. The exercise 14 problem. Find the inverse of the matrix 2, 1, 4, 2 if it exists. Find the inverse if it exists. Find the inverse if it exists. This is the problem. You consider A equal to IA. A is 2, 1, 4, 2 equal to I means 2 by 2 matrix 0, 1, 1, 0 into A. A divide the all 2 by 2. What do you get? 2, 1, 4 by 2 is 2, 2 by 2 is 1 equal to 1, 0. Similar operation, divided by 2, the second row 1 by 2, divided by 2 is 0, A. Now, R1 is R2 minus R1. You consider R1 is R1 minus R2. That is equal to 2 minus 2, 0, 1 minus 1, 0, 2, 1 is equal to 1 minus 1 by 2, R2 minus R1 minus R2, 1 minus 1 by 2, 1 by 2, 0 minus 0, 0, 1 by 2, 0. Here also the inverse does not exist because all the elements in the first row are 0, therefore inverse does not exist. Since R1 elements are 0, inverse does not exist. For this problem, I can say only simple idea. If the given matrix is 2, 1, 4, 2, you multiply the diagonal elements first. 2 2s are 4, and again this second diagonal 4 1 is 4. Subtract them, you will get 0. If it is the case, you can immediately say the matrix doesn't have inverse. If the simple idea 2 into 2 4, 4 1 is 4, subtracting will get 0. Hence it has no inverse. Instead of applying the row operations or column operations, we can immediately say by expanding along, multiplying the diagonal elements or subtract, you will get 0. You can immediately say the matrix has not inverse. This is only a simple idea and you follow it. Now I will stop here because we have completed some important problems in the exercise 3.4. So next concept we will see in the next video. Thank you.